30 degree, 60 degree, 90 degree rule for a right angle triangle. If 30, 60 and 90 degree are the angles inside a right angle triangle, let's label them. Let's assume that this angle here, this is 30 degree angle, this is 60 degree angle, and this is 90 degree angle. Now, whenever we are dealing with a right angle triangle, it's always good to label the triangle and its elements according to the nomenclature or naming conventions. In that case, this side will be labeled with small b because this is side opposite to vertex B. This side will be labeled as small c, which is hypotenuse, and the other side, this will be labeled as small a, which is side opposite to vertex A. Now, the side opposite to 90 degree is hypotenuse, and let's take its length as standard. If we assume that this length is equal to 2x, then what is half of this length is x. So A will be half of the length of the hypotenuse. So this would be simply x. This would be x, and this would be under root 3 times half of the length of hypotenuse. So this would be under root 3 times x. This is the ratio. Whatever is the given length of hypotenuse, you can take half and write that as length of the base, and then multiply the length of the base with under root 3 to get the length of the perpendicular. It will take a couple of questions for you guys to get used to it, but this is a wonderful rule which will also help us in finding standard trigonometric ratios. Anyway, if you require a proof, let's consider, so let's do a proof. For proof of the rule, we are going to consider an equilateral triangle. Equilateral triangle means which has all three sides equal in length. For proof of the rule, consider an equilateral triangle. Equilateral triangle ABC. Let's consider this as A, this as B, and this as C. Since this is equilateral triangle, so if this side is taken as x, this side is taken as x, then this side will also be x. Because all the angles here, here, and here, all the angles are 60 degree. 60 degree here and 60 degree here. Only then this triangle can be equilateral triangle. Now let's consider drawing a angle bisector from here which meets BC at point D. It is interesting, not only this is angle bisector, which means that angle 30 degree on this side and angle 30 degree on this side, this is also perpendicular. This is a perpendicular bisector as well. In case of equilateral triangle, angle bisector is also perpendicular bisector. In case of, note, okay, let's write down it here. In case of equilateral triangle, angle bisector is also perpendicular bisector of the opposite side. So now we know that D is bisector of the side BC, which means that half of x is on this side. This is x by 2 from here to here, and half of x is on the other side, x over 2 on this side. Now we have altitude AD. Let's name this as H. Now from this triangle ABD, from triangle ABD, A, B and D, which is of course a right angle triangle now, because we wrote in case of equilateral triangle, angle bisector is also perpendicular bisector, which means that it's making an angle of 90 degree here. So if this angle is 90 degree, then by Pythagoras theorem, from triangle ABD, using Pythagoras theorem, what we have here is AB square, which is hypotenuse. AB square is equal to BD square plus AD square, which means that x square is equal to x by 2 square plus h square. Because we know what is x, we just want to find out the value for h. This means h square will be equal to x square minus x square over 4. And now if we want to get rid of this square root, we will have, this implies h will be equal to, so this would be, let's write this as h square still, and this would be 4x square minus x square over 4, and here we have h square equal to 3x square by 4. And now if we take a square root on both sides, because length is only positive, so h will be equal to under root 3 divided by 2x. Initially, what was the length of the side? That was x, and now this is h is equal to under root 3 by 2x. So this is how we can find out that if this side is 2x, then what would be the length of the perpendicular? That would be under root 3 times half of the length. So this was, if you look at here, x was the length of the side, under root 3 by 2 times length of the side. And same thing over here, this is the length of the side is 2x. So this is what is half of the length. Half of the length is x. So this under root 3 times half of the length. So this is how we came up with this length under root 3x. And similarly, we can find, and we already did, in fact, in this proof, that this base is half of the length of the hypotenuse. So this proves our theorem. This proves, so if hypotenuse is equal to 1, then side opposite to, so this was side opposite to 60 degree. 60 degree would be equal to under root 3 times half of hypotenuse divided by 2. Half of the length of hypotenuse, and side opposite to 30 degree would be equal to simply hypotenuse by 2. So if this hypotenuse is equal to whatever that hypotenuse is, if that is the case, then this would be under root 3 by 2 times 1, which is equal to under root 3 by 2, and this is equal to, if hypotenuse is equal to 1, this would be 1 by 2. So now let's take an example here. Example is that let's consider that this is a right angle triangle. If this is a right angle triangle and this length is equal to 12 centimeter, then A, B and C, what would be, and this is angle 30 degree, this is 60 degree, and of course this is 90 degree. Then what would be the hypotenuse will be equal to 12 centimeter, and this will be half of it, that will be 6 centimeter, and this will be under root 3 times 6 centimeter. So this is how we can calculate lengths of the sides of a right angle triangle if any one of the side is known. This works if there is only one side which is known, but the condition is that we should have the angles of triangle as 30, 60 and 90. This is very useful result, and we will use it again while calculating trigonometric ratios for 30 degree and 60 degree.